Have you ever wondered, what is a Pi cluster? Or why would anyone bother building one? Well, today I'm going to try to answer those questions by setting up a Pi cluster for my home lab. I'm going to go over the pros and cons of Pi clusters and discuss some of the software that you can run on a cluster that you might want for your home. So a cluster is just a series of computers working together to solve a problem. Modern computers are quite powerful by themselves, but there will always be a limit to how much computing power you can get from a single processor. Networking multiple computers together into a cluster allows you to continue to scale your system performance. This is why the largest supercomputers in the world are clusters. As of this recording, the largest supercomputer in the world is Frontier. It has over 9,000 AMD EPYC CPUs with over 37,000 GPUs and costs around $600 million US. Many of us don't have millions of dollars to spend on a supercomputer, nor the opportunity to even access one. This is where Raspberry Pis come in handy. They offer an affordable solution for cluster computing at home. Pi clusters were introduced soon after the first Raspberry Pi was launched back in 2012. The early Pi clusters were largely used for academic purposes in the growing field of parallel processing, which involves optimizing algorithms by breaking them down into smaller operations that can then be run on separate threads at the same time. They were especially useful in the subfield of distributed computing, where a workload is broken up to be run on separate computers at the same time. Back then, there weren't a lot of CPUs that had multiple cores. One of the few consumer CPUs was the Intel Core 2 Duo, which still only had 2 cores, as the name implies, and could only handle 2 threads at a time. To work on larger problems, other solutions had to be explored. Pi clusters became a cheap, affordable solution for experimenting with parallel or distributed algorithms. You only needed a cluster with 3 Pis to beat the latest consumer Intel processors in terms of number of threads. Modern processors, however, can include a large number of cores. A single AMD EPYC processor can have 64 cores and support 128 threads. The latest Raspberry Pi 5 only supports 4 threads at a time, which means that you would need 32 Pis in a cluster in order to equal the same number of threads. Software options for Pi clusters were limited and often required writing your own code using low-level APIs such as MPI. Fortunately, since Pi clusters were first introduced, a lot of open source software has been released that can turn a Pi cluster into a useful and practical addition to your home lab. Modern Pi clusters are often set up with a combination of Kubernetes and Docker. Docker is a system for packaging and executing an application in a container. A container stores all the libraries and dependencies that an application needs to run separate from the ones installed on your OS. This allows an application to be executed on a new computer without the need for a setup or installation process. Kubernetes is a containerized application orchestration system. It will decide which application needs to run and on which system in the cluster. By using applications already packaged in containers, you can add or update an application on the cluster without having to install anything new on the Pis themselves. So, you may be asking yourself, why bother with containerizing applications and setting up a cluster of Pis when I could just run the applications that I need directly on a single server? The main advantage that a Pi cluster has over a single server is redundancy. I can remove a Pi from a cluster, apply any software updates, or fix any configuration issues and re-add the Pi back to the cluster without affecting the software running on the cluster. Redundancy is very important for industrial applications, but may not be as important for small home lab setups. Applying updates to my home server usually doesn't take too long, and the only person that it affects is me. So again, why would anyone bother building a Pi cluster? Pi clusters are still very effective teaching tools. If you are an engineering student or otherwise working on polishing up your resume, Pi clusters are a great tool to gain professional experience in modern software development strategies. You can use the same open source software stacks that big companies use, only at a much smaller scale. With a little practice, you can talk competently about Docker, Kubernetes, Grafana, Argo, and so much more during your next job interview. But for most of us, we do it because we can. It is a great way to test your technical skills, and it allows you to show off how you can solve simple problems using overly complicated solutions. You don't need that much to start building a Pi cluster. All you need is 2 or more Pis of any generation with power supplies and a switch. Clusters can be extended with a number of different Pi hats or USB devices. Some common options are to add a USB hard drive or an M.2 hat to support an SSD. There are also a number of free 3D printable cluster cases available online. I added PoE hats to my Pis so that I could power them from a PoE switch and mounted them in a 3D printed rack mounted case that supports up to 6 Pis. One of my Pis has a Coral AI Google TPU installed so that the cluster can support AI applications. If you don't want to build your own software and containerize it yourself, there are a number of online registries for containers, including Docker Hub, so finding open source applications to run can be easy. Now I'm not going to go over every application that you may want to run, but there are a few common ones that you may want to consider. The first one is Grafana. It is a highly configurable interactive analytics visualization web application. You can use it to view real-time data on a customizable UI. It has built-in plugins for pulling in data from a wide variety of data sources that it can use to populate user-defined dashboards. The dashboards can be created and edited through a simple and easy-to-use UI. You can select the type of graph that you want to create from the right-hand side. Then you can select the data source and the metrics from that data source that you want to view. You can also choose any filters or operations that you want to apply to the data. If you have data storage attached to at least one of your Pis, you may want to consider launching a database server. Two popular options are Postgre and MongoDB. They are often used in other apps such as Grafana, and they are easy to set up if you want to create your own web applications. Now, if you plan to use your Pi cluster for app development, a great option is Argo. It helps automate the deployment of apps on a Kubernetes cluster. You can create an accessible code repository with the necessary Kubernetes config files on GitHub. Argo can then be set up to read those configurations and install them on a cluster. Argo can be notified when the code repository changes, so that it may pull the latest configurations and push them to Kubernetes and keep the cluster up to date. I hope this gave you a better idea of what is a Pi cluster, why would anyone build one, and how it can be used. If you have any other questions about Pi clusters, please leave a comment below. If you liked this video or found it helpful, please give me a like. And don't forget to subscribe for future content. Thanks for watching.